Hi guys, today we're doing longest substring without repeating characters. So we're given a string s and they want us to find the length of the longest substring without duplicate characters. So we're given some examples down here where s equals the string and we output 3 because the answer is ABC with the length of 3. And same with these two, right? So in this one, the longest substring without repeating characters is just a single b with a length of 1. So if we walk through like how we actually find the longest substring, basically we're going to want to iterate through the string character by character and check each character that we visit. So like we start with a, which is at 0 in this one, and then we check if we've already seen a or not, and we have not, so we can include that in our longest substring currently with a length of 1. And then we'll check this b, and have we already included a b? No, so then we'll add the b with a length of 2 now, and then we'll check this c. Have we already found a c? No, so then we add c, and then our length is now 3. So then we continue through with a, and then do we already have an a? Yes, we do. So then we have to remove characters from the left side, so until we no longer have 2 a's. So then we'll remove the a from the left side, and now we have this. And then we're good because we now every character is unique, right? So then this still has a length of 3. And then we'll check this b. Do we already have a b? Yes, we do. So then we remove the b on the left side, and we're left with this with the length of 3. And then we'll continue with this c. Do we already have a c? Yes, so we remove characters from the left side until we no longer have a c. And then now we have ABC. And then we check this b. Do we already have a b? Yes, so then we have to remove characters from the left side until we no longer have 2 b's. So first we'll remove this a, and then we have this. But then we still have a b on the left side, so we need to remove another character, and now we're just left with CB. And then we'll check this b at the end. Do we already have a b? Yes, so then we have to remove characters from the left side until we no longer have 2 b's. So we'll first remove this c, and then we'll just have b. And then we still need to remove a b because that's still a duplicate. So then we're just left with this last b. And then at this point, then we're at the end of the string. So then we're done. And our longest substring that we found was with a length of 3 over here, right? So that's how we get that answer. So to keep track of what characters we've already visited before, we'll want to use the hash set of characters. So let's initialize that. And then we'll, since this is a sliding window, right, because we're checking each window as we slide along the string, we'll want a left pointer to keep track of the left, like the left side of our current substring, and a right pointer to check the right side of the current string. But since our right pointer is always just going to increment by 1 as we go through the entire string, we'll just use that in our loop. So then, yeah, our right will just keep increasing through our loop. And then we also need to keep track of our current longest substring. And so I'll use a variable called max to do that because it's our current maximum length of substring, right? Okay, and then in our loop, so as we're iterating through this string, if you remember, we need to first check if we already have this character in our set or not before we just add that to our length, right? So for example, when we were over here, right, we needed, like once we added this b, like our right pointer would be pointing at this new b over here. We need to check if we already have a b in our set, and if we do, we need to keep removing characters from the left side until we no longer have a b. Or a duplicate b, right? So while set contains the character on the right side, which in this case is b, then we will remove the characters on the left side until we no longer have a duplicate b. So, and then we also need to increment our left pointer every time we do that. So here, right, our left would be at 4, because that's where this A is. We remove the A, and then we increment left to 5. And so now the left is pointing at this B. And then we remove this B from our set and increment left to 6. So then it's left is pointing at C, and then we're good. So we exit this loop, right? So after we exit the loop, we also need to add our new B onto our set. So we'll add the new character from the right side. And we didn't want to do that up here because we're checking if it while the set contains this the character on the right side, which is B. So if we have this like up here, then we're gonna lose this B, which we don't want that to happen. So we have to do that after we've removed it from the left side. And then we want to update our maximum length after we've done all of this as well. So after we remove that B, then our length would be here, right? So our max here would be the maximum between our like this current length or the previous maximum. So we'll use math.max, our previous maximum, and we're going to say right minus left plus 1. And that is because, so if I copy this over, and let's put indices so it's clear. Oh. Okay, right, so if we, look at here, our right is currently 6, our left is currently 5. So 6 minus 5 gives us 1, and then we need a plus 1 to get the length of this substring. So that's how we get that. And our previous max would have been more because it was 3, right? Because it was this one. And so this one, if like, let's pretend we were calculating this one from before. So then 5 minus 3 gives us 2, and then 2 plus 1 gives us 3, which is the length of this substring. So that's how that works. And then at the end, we just want to return our maximum. So let's check that. Okay, and then so our time and space complexity. Our time is going to be O of n, where n is the number of characters in this string. So that is because we need to loop through every single character in this string, right? Because to check what the longest substring would be. And we do that in this for loop, where right it starts from 0 and then we go all the way until the end of the string, right? And this while loop does not really add any runtime, like it because it gets amortized, where basically, because as we add stuff on the right side, we're not like rechecking characters like every character against every other character. We're just removing things from the left side. And so this still gets bounded by whatever our right index is pointing at, right? So like in the beginning, right, if right is 0, then it's bounded at 0. If right is 2, then it's bounded at 1, it's bounded at 1. If it's 2, it's bounded at 2, and so on until n. And so this left pointer is just like, or not left point, this while loop is just following the right pointer along. So it's not adding any runtime. And then, yeah, so that's pretty much it for the time complexity. And then space complexity is going to be a little bit more confusing. It's O of minimum of n and m, where n is number of characters in our string s, and m is number of, I guess, characters allowed in the input, and I'll explain what that means in a second. Basically, so what I mean by number of characters in the input, so like for example, if we're only allowed to have lowercase letters in the American alphabet or something, right, then m would be 26 in that case. Or yeah, I'll just use that as an example. But so if, and then n is the number of characters in s, and it's just going to be the minimum of those two numbers. And I'll explain what I mean by that. So let me copy over an example. where let me put this on a new line actually. So in this case, right, if S equals A, B, C, D, E, F, G, then in this case, actually, let's just leave that. So we have 1, 2, 3, 4, 5, 6, 7. Right, we have 7 unique characters here. And so our space complexity would be O of minimum of 7 and 26 if we just use the American alphabet as an example, right? Like all lowercase or something. So then that would give us 7 because 7 is the minimum of these two numbers, right? And so, right, because we also have our, where this comes from as well is our hash set, because we have to store every character in the string as we go in our hash set, right? And so worst case, if every single character is unique, we're going to be storing every single character in our hash set, which in this case would be 7, right? Because we have 7 unique characters. And so our longest length of substring would be 7. That has all unique characters, right? But if instead we have something like this, then our space complexity would be the minimum of, this has 27 characters, and we only have 26 in our possible characters to choose from, right? Like that are in our input, because there's 26 characters in the American alphabet. Then our space complexity would be 26 because that's the minimum of these two numbers. Because since we have more total characters here than the number of allowed unique characters in our input, we're not going to store any of them more than once because we only want unique characters. And so, right, this first A is not going to be included. We're just going to have this last part, which is a length of 26, and that's what we're going to be storing in our set. So it would never store more than 26 because that's the total unique characters that are allowed in our input. Yeah, sorry if that was kind of a long-winded explanation, but I hope that made sense. But yeah, that's it for this problem. Thank you guys for watching, and let me know what problem you want me to do next. Thank you guys. Bye.